Hello, everybody, and welcome to this webinar today. We're going to open up here. I'm going to tell you a little bit about myself so you guys can get some context on where we're coming from. But welcome to this webinar about what RIZE offers and also really specifically an actual part of the month, right? So to give you guys some context, my name is Alex Orfanos. I'm an application engineer here for RIZE, and we are doing this part of the month. It's kind of an application-centric webinar where we're going to talk about the actual thing that we're printing. But more importantly, too, we're also going to tell you about the systems that are making these parts. So kind of a well-rounded view of what RIZE offers, what the system is. And I encourage everyone to please ask questions. Kirill, my colleague here, is going to be running the chat and moderating. So while I'm presenting, if you guys want to add any kind of questions, anything in the chat, please feel free to do that. I'm gonna have a section at the end where we're gonna go over that, but that's it. So please definitely ask your questions. We're here to help share some information and give you guys a little break from everything to learn something new. So this week is exciting. This is our first part of the month. We're gonna dive into the part itself, not only from the design aspect, because there is a specific way to design things for 3D printing, but also the platform itself. We have a very cool case for the first part of the month where we're going to be discussing a part that was made on 2 of our systems. So the XRIZE, kind of the flagship color printer that we have with RIZE, and then the 2XC as well. So we're going to get into that here in a little bit. But just to give you guys some context, I've been in the 3D printing industry for a few years now. I've been 3D printing, at least at home from the FDM side of things, for about 5 or 6 years at this point. So I've tinkered, I've gone the maker route with a Prusa and Creality and done that, and multicolor printing in that state is definitely not the easiest thing to do. It's definitely more cumbersome than it is easy. And one of the things that's really great about the RIZE system, just as an engineer, speaking specifically with the times that we're dealing with, is the fact that I'm able to comfortably have both these printers, the XRIZE and the 2XC, both that helped make this part here, in my home. And not only that, because that enables me as an engineer and I'm able to keep working and developing and doing all that at home, but I'm able to do it safely thanks to what RIZE does as a material science platform and an overall solution. So I definitely feel very lucky and grateful that I work for a company that not only allows me to bring one of these printers home, but it also makes sure that I'm safe. I mean, even my FDM, my maker printers, are not that safe. And so we'll discuss a little bit about that here. So if we talk about the part itself, we have two parts to this whole spinning assembly here. We have the stand assembly on the left there. That is the base here where all the color is for this part. That was made on the XRIZE system. And the helical gears on the right were made on the 2XC. Both used the Rizium material platform, so Rizium GF for the color stand assembly on the left. The white helical gear was in Rizium GF, and the black helical gear is in Rizium Carbon. The XRIZE used a Release 1 ink, which allows us to do a very easy, barely no time spent in the post-processing of the part itself, where the 2XC uses our Rizium support material. And then, of course, the inks that were used in the XRIZE system, CMYK, those were used to bring this vibrant part to life. And a little bit about RIZE for anyone that's completely new to us. RIZE is the first company that invented the world's first safe full color and composite industrial 3D printer. And this comes from our combined experience. The people at this company, especially Eugene, our CTO, has been involved in these color printers and it was involved in some of the early ones, and he made it a point to create a system that was safer. We were just given the UL Green Guard for our XRIZE, and our RIZE 1 was the printer that got the first UL certification. That means 0 emissions. That means even VOCs and particulates. That's the combination, and that's the inks and the materials. So we're able to create these vibrant full color parts have intelligent parts like this jig and fixture here in the middle here, add QR codes, labeling, revision changes, and also where the biomedical space is exploding for the need of a safe system that's able to provide color that can be put point of care right installed somewhere, just like I have it here in my home. So those are the areas that we're helping provide value right now. And if you want to learn more, of course, the plug is obviously RIZE3D.com. You can learn even more about this. Portfolio itself, we have, like I said, we started from the material science with the composite materials, RIZE One, RIZE glass fiber, RIZE carbon, Rizium carbon, and those are available to print on all of our machines. It's the color aspect that is really perfect for the XRIZE system, where it uses the inkjetting system. We'll talk a little bit about that. But we have this our whole focus is around what we can add value to by starting from a material science perspective. So we'll be talking about two of these systems, like we said, the XRIZE and the 2XC. Now the XRIZE uses a augmented polymer deposition. That's our technology, where we're able to combine that material extrusion that you expect from FDM, and then we have functional inks used in material jetting. So we're able to infuse our materials with the actual color on the inside of the part. You know, if I'm rubbing this part here, right, it's not like it's the color is washing away. It's actually embedded into the material, and then another layer is added to the outside, which then again reacts to the material. So you've got the material on the outside protecting the color on the inside, and you're using it in a very efficient manner. There's other things too. Again, if you want to reach out to us and ask more questions later, we'd be happy to. I want to keep this part focused, but I want to give you an idea of what our RIZE platform is about. Our materials, our RIZE One material, Rizium One, was granted the USP Class 6. So biocompatibility is available there, and then our composite materials, glass fiber and carbon, use that same base material. So you're getting not only the ability to have moisture resistance and chemical resistance with the cycloolefin-based compound, but you're able to have zero to minimal emissions. So we'll talk a little bit more about this, and that also includes the inks as well. So we talk about the spectrum of materials that we have available: Rizium One, Rizium Carbon, Rizium GF, and you can see all the different parts that we're able to achieve here. The moisture resistance is a huge part of the cycloolefin-based composite. Less than 0.01% moisture absorption, which means you don't have to dry your material beforehand. From a maker's perspective, I've had to do that plenty of times, and it's hard to keep up with. But with our material, it's naturally moisture resistant, so that helps with any kind of applications where it has to see water, but also just in the storage. We're also chemical resistant as well, so we're able to put these parts in high acidic, high basic, polar environments, where we're able to expose these parts to the chemicals that you typically wouldn't be able to do with typical FDM parts, and put them in an application that you wouldn't ever be able to before, and the color stays with it as well, because again, color is infused inside the material, and then the material on the outside helps protect it. There's also UV resistance. If anyone's had a color part and left it on their shelf at work, on their window, if you're lucky to have a window, some parts don't last very long due to the UV interaction it may interact with. But again, because of the infusion that we have with our APD technology, we're able to have tremendous UV resistance, and of course sterilizability. That comes in handy, of course, in today's world, because of everything that's going on with COVID, but also in medical environments and wherever else you might want to be. You're able to use ETO and gamma approaches to sterilizing your materials. Autoclave won't work, unfortunately, due to the high temperatures, but you have those two options available to you to sterilize, where even just typical FDM parts you're not able to. So with the XRIZE, it's really based around three things. It's safety, intelligent parts, and workflow, and also the color aspect. So that's kind of the trifecta that the XRIZE system, our flagship system, is able to offer. Now, if we look at the XRIZE, again, just giving you guys a little bit bullet points here. Again, RIZE3D.com for more info. You're getting the full ability to have the whole material system, Rizium 1, glass fiber, carbon, release, and color inks, get auto bed leveling. You just put the bed plate in and you start your print and you're good to go. Again, zero emissions from a safety perspective. 820,000 plus colors that can be used at any time during the print. Again, as you saw in this part that we'll touch in just a second here, and we'll go into more. Release ink for basically zero post-processing. You get the OneTouch software and slicer for the optimization of printing these parts, RIZE Connect, and more. And again, go to rize3d.com to learn more about that. Reach out to us. We'll be happy to talk to you more about it for your specific needs. And then the 2XC, here you're getting the ability to print the composite material. So glass fiber, carbon, and we also have the support material that you're able to use here. Dual nozzle capability, connected workspace. I was just playing around with the connectability. I'm able to watch my print as it's going at the same time, so I don't have to be in the same room. I can be mobile, I can be active, which is great. Flexible build plate, which is similar to what I have with my Prusa here. And it's a budget-friendly option for prototyping with our materials. So the big thing here is no color or release ink. But let's talk about the part, because as an application engineer, this is where all the magic happens. So our part model here was designed, I used Fusion 360, but you could use any CAD software. This is just the one I had in front of me at the time. My goal here with making this part, I designed this with my colleague Anthony at RIZE, and our goals were to have a moving assembly, minimal supports, and a lot of surface area so we could apply color in specific areas. So that's where we started. The gears, what we had to do was make left and right hand helical gears to allow the spinning action here, as you can see. So that was very easy with a nice generator inside the software. The base itself, again, minimal material. We wanted these posts, another part here. We wanted these posts to spin, but we also didn't want them to be sloppy. You know, we wanted them to spin true to the center as much as possible. We want it to be fast. That's why we went with the thin overall height. And again, like I said, lots of room for textures and color. And so you can see here, we used just a kind of an opening here. Any kind of 3D printing process, really any manufacturing process, you're designing for that specific case. So the way we went about this was adding anywhere from a 0.4 to a 0.6 millimeter offset. For our technology, that's specific, but that's generally around the same. If you're used to creating offsets for assemblies with parts in FDM or FFF or things like that, it's nothing new. But essentially, we're looking at the keyway here. That there's a 0.4 millimeter difference offset there, and then we've got a varying 0.4 to 0.6 here, which allows for these to spin nice and freely, but not move completely out of place. So that was nice and easy, and this is what a lot of people end up with when they're used to monochrome printing or printing in one color. You get kind of this nice simple part, but there's so much more to this part that we're able to do by applying colors and textures. So in our OneTouch software, a lot of this work could have been done directly in here. That's one of the great things about the OneTouch software, is it minimizes all the extra stuff that you have to do on the outside. Now, there's powerful technology like Magix or even SolidWorks, you're able to apply color to surfaces. All of those are totally fine. In this case, what I ended up doing was I wrapped the wood grain and the colored liquid on that front face underneath the RIZE. I used basically the technique in Magix to stretch that over because it just happened to look better for the process I was looking at that. But again, a lot of this could be done directly in our markup section here, which we'll touch on a little bit. And then the bottom, as you see on the right, that color spectrum was also applied to the bottom surface. And then in OneTouch, we used markup to add the logo and supporting text and the QR code. And so this was helpful for our application in the XRIZE. So if you look here, you can see the paint option allows you to select individual surfaces, apply a specific color, and you've got the entire spectrum here to use. So you've got a lot of different options, whether you're doing a single triangulated surface, or you want to stop a specific angle, select the whole surface. You have a lot of options there. And then there's obviously the markup section. So here you're able to add text like we did here with the glass fiber and the carbon fiber. You're also able to add photos. So here, like I said, I could have also just simply added these textures as a single surface to project down on the part, and that would have worked just as well. And so if we look at the top and bottom view for both parts here, it can be a little bit more specific of where we actually applied this. So the QR code was very simple. We took essentially just a picture there, and I'm pulling up my phone here, and you can see right away that QR code works. So that's one of the great things. You can have so much data. This QR code goes to our website, rize3d.com, but you can add technical data. Let's say you're a CMM operator and you have all of the documentation that you need to use, maybe you even have a specific procedure just for fixturing to start the job in the first place. All of that can be loaded into a QR code. You can add revisions, and it can be added really, really simply in our OneTouch software. There's also the logo itself. We're seeing a lot of folks who are entering into the color space and wanting to apply their own brand, which is smart. It's a great business thing to do, and it's nice and simple to do with our XRIZE system. Then, of course, text added. We wanted to specify which side the actual gear went to, because each has its own specific left hand and right hand designs for it to spin properly. And on the back, we added build data. So adding specific things to the part so you're not guessing. There's a lot of things that we're so used to doing as people using 3D printing technology, even from just a monochrome perspective, that you don't get if you don't use a color system. But the real trouble with that is getting something that's safe enough, or having the infrastructure to put something in that requires environmental controls and all those other things, never mind operators that are willing to put themselves potentially at risk, where PPE. With the XRIZE system, you're able to take all of that out and add the value to the part itself without having to worry about all of that extra stuff. So I can't stress that enough. Again, can't say how lucky I am to have this in my own house and feel safe about it. It's a big, big deal. So let's talk about the stand assembly. Let's get into a little bit of the actual part data, print data. So here is our part here inside of my XRIZE. This just finished last night. Print time, 2 hours and 33 minutes. That's for the raft and the part. That's the entire process. We're using, we used RIZE GF as the base material. We had the CMYK inks and the release ink used, which basically brought our part cost to $7.60. And the post-processing is under a minute. And I'm actually going to do this for you right now. XRIZE. I took this off the plate earlier. So here is the part right off the printer. And here, in seconds, without any extra tools, got that raft right off. Move these posts. And there you have it. There you have it, folks. Spinning, articulating, all set. So seconds to do that, under a minute. You could have timed me if you wanted to. And here, again, we're showing just the ability to not only print on the top layer, but all layers as well. We're doing the bottom as well. We're able to get clarity and color without worrying about the actual material drooling into the raft or into the other areas. We used a 0.25 millimeter layer height. That doesn't mean that you can't go lower. I think one of the things to definitely make clear here is that with our system, we're able to go, we've optimized down to 0.125. You know, our focus here is stability. So we want to provide something to our customers that works every time. And so that's why we've gone to 0.125. But again, if you've got specific projects that you're looking to do, not only does our system allow us to be creative in the way that we work, we're also looking to do creative solutions to help you guys get your projects done. So if there's, again, if you guys want to reach out, I'll have my contact info at the end. I'm happy to discuss more about whatever projects you're working on. Shell thickness, 0.8 millimeters. It's 2 wall lines. And infill was set at 66%. The great thing about the GF material I've seen is it prints really well at solid settings, which I can definitely say using a typical FFF printer, like a maker style printer, sometimes that's something you really have to play around with. But our material, you get the strength of the composite fibers, and you also are able to print larger. Now, you could obviously reduce that to save some time, save some material. And our infill pattern is our optimized RIZE fill. If we go over to our helical gears, we've got, again, on the RIZE 2XC, this is the slicer software here, the 3D Walk software. So here we sliced it two different ways. One nozzle was running, in the first case, Rizium GF. The other nozzle was running Rizium support to build the support underneath the gear. And then we did the same thing, but swapped out carbon for the GF. The print time was 1 hour and 21 minutes for each. The material, again, used, we used the Rizium support material. Part cost was $2.12 for each one, and the post-processing took minutes. One specific difference I do want to talk about, for the XRIZE is going to use the same material that the part is made out of, and then jet a release ink into that layer between the support and the part, which allows, like we just showed, the release to happen very smoothly. It also helps us achieve darn near uniform surface finish. So one of the things you can definitely expect, and you might have to tweak and spend time laboring over, is getting all the surfaces, especially the supported surfaces on a FFF-based part, to actually look the same, or you may have to do some extra work afterwards. One of the great things with this material and the way that our support material reacts on the 2XC, that supported surface is very, very smooth, and I actually favor that supported surface over perhaps even the top surface, which may not be the way that most people are used to. But again, the 2XC, again, which if you want to learn more about, RIZE3D.com. We've got an unboxing video where we opened our first one in our office and set it up. We also have a promo video, and obviously you can learn more. But we used a 0.2 millimeter layer height. We had a 25% infill, and we just used a grid infill pattern. And you can see the tool paths there on the middle of the page. And so at the end, to kind of tie this all together, we used our XRIZE that has that UL green guard, again, printing in color safely without even having to worry about where it is or who's operating it. Combined with the 2XC, this part total printed in 5 hours and 15 minutes. And now that may have been stackable, right? Because it was between two printers. So actually it's closer. If we printed them at the same time with both printers, it's really closer to 3 hours. The materials used, again, Rizium glass fiber and Rizium carbon for the gears, and then Rizium glass fiber for the base, and our color inks and release ink. Total part cost is $12.04, and the post-processing was done in minutes. A lot of this, really, I want to point out for anyone that may be new to this or new to color, this part is done after that post-processing is done. There could be some extra work you might want to do. For instance, you may want to use, in our case, we use D-limonene to smooth surfaces and bond parts together, which if you're used to ABS and using acetone, that can obviously get a little messy and obviously more safe to deal with. But this full color part has functionality. It has data attached to it with the QR code and the supporting text on the bottom, uniform surface, a spinning assembly, a functional part spinning assembly for $12.04 for part costs. That comes with the amazing materials that we're offering and the safety that it provides not only the operators but an entire company. And again, like I said, enabling an engineer like myself or like you, enabling you to do your work wherever you are, because in today's world we never know where we might be working, whether it's in the office or not, or in case my basement, which again, welcome to my home here. It allows us to have a part where that part cost, when you really think about what comes with it and what the alternatives are and the safety cost that's never included in the part cost that you may discuss, this is all included, and you're getting your part quicker and faster and safer, of course. So that is it for talking for a few seconds here. I'm going to open it up to questions. Thank you, everyone, for joining me. I would love to know from you guys whether you have any questions, of course, but also if you have any recommendations for parts of the month for the future here. We're definitely gathering ideas. We'd love to know what types of parts you would like to see. Specifically, if you have any type of specific applications that you may see functional color being used, having more intelligent workflow around things, maybe definitely in the jigs and fixtures. I know we'll be going that route soon, but any type of application that you're looking to have us do on a part of the month, please let us know. We would love to do that. You have my contact info here, alex.orfanos@rize3d.com. Feel free to reach out about this or about anything else that RIZE is offering. I'd love to chat with you more and put you in touch with the right people. Of course, if you want to request a sample part too, feel free to do that in the chat here. We can get back to you. And that's it, folks. That's it. I'll leave the chat open a little bit longer. Kirill, if you've seen anything, please let me know. I'll give folks a second to breathe. Ask any questions. And in case you guys were wondering, the ink cartridges themselves, here is our release ink here. So these very easily are installed down here. You've got your release ink, CMYK over here. You've also got down here is the container that any kind of excess during the process that's being used, it gets stored there. And then here we have our material bay. So you're able to add 2 different spools in the XRIZE, load that ahead of time so that you're good to go. Here we have our RIZE 2XC filament here in this box. And that's it, folks. All right, I will leave it there. You have my contact info on the screen. If you have any other further questions, please feel free to reach out. Otherwise, stay safe out there, be good, and thank you for joining us for this webinar. We appreciate it. See you next time for another part of the month, next month in October. Again, ideas, let us know in the chat or later. Thank you. Have a good day.